We're going to use the color of sheep's wool for the next few examples to show the basics of Punnett squares and Mendelian law. White wool is going to be our dominant trait, and black wool is going to be our recessive trait. We will represent white wool with a capital W and black wool with a lowercase w. If we were to mate a white-wooled sheep who had a parent that had black wool with a black-wooled sheep, then what could their offspring be? First, we need to figure out what the genotype of the white-wooled sheep could be if they had a parent with black wool. Because we know that one of her parents had black wool, then she is going to have one of the recessive traits for black wool of little w. But because we see that she has white wool, we know that she has to have the dominant trait as well. So we can tell that our sheep is going to have the genotype of big W, little w. If we cross our original heterozygous white sheep with a homozygous recessive black sheep, we can figure out the Punnett square like this. We know that our white sheep can give two different kinds of eggs. One possibility would be a big W and the other is a little w. Our male sheep only has one possible kind of sperm to give, and that would be the recessive trait of little w. By filling in our Punnett square, we can see that our white female sheep could give some of the offspring of the dominant trait and some of the offspring the recessive trait, whereas our black male sheep can only give the recessive trait. By looking at this Punnett square, we can tell that 50% of their offspring could have white wool and could be heterozygous, whereas the other 50% could have black wool. Now, let's look at sex determination and look at specifically which sex chromosomes the male and female sheep could give to their offspring. So, male sheep are going to have two sex chromosomes and will have both an X and a Y sex chromosome that it can give. Whereas our female sheep, which we have chosen to be white, has two sex chromosomes as well, but they're both X and X. Once again, we'll make a Punnett square to determine what genders their offspring could be. We will start with our white female sheep. Because female sheep only have an X chromosome that they can give, the only eggs that they could give to their children are X chromosome eggs. In the male sheep, which we have previously determined to be our black sheep, they have two different sex chromosomes, and so there is the possibility of either giving an X sperm or a Y sperm to their offspring. Take a second and see if you can fill out the Punnett square, and then determine the probability of them having a boy or a girl. So hopefully your Punnett square has ended up looking a little bit something like this. From this table, we're able to calculate the probability of having a boy or having a girl. In this case, it would look like that we could have a chance of 50% of getting a boy and also a 50% chance of getting a girl. When faced with a genetics problem that complies with the Mendelian laws, you can always make a Punnett square to organize the information given and then figure out what your outcomes could be.